Good morning, everyone, or good afternoon. Today is the start of Q4. For our lesson for this week, weeks 1 and 2, we go with Module 1, Behavior of Gases. First thing that we need to accomplish is to answer the Q4 pre-test or pre-assessment. So this is a 20-point pre-assessment or pre-test. The first topic is about kinetic molecular theory of gases. Now, most gases are invisible. We can name as many solids and liquids that we see around us, but not gases. It is only the very few colored ones, like the black smoke produced by smoke belchers, that can be seen. Unseen gases are present in a bottle that seems to be empty, production of food by the plant, playing our favorite sports. Gases are also made up of molecules that behave differently. Most of the properties of gases can be attributed to the random and scattered arrangement of its molecules. Other because they have very weak intermolecular force of attraction. The first learning task is you have to read the kinetic molecular theory of gases. So here we go. The Earth is surrounded by the sea of gases called atmosphere. It is mainly composed of oxygen, nitrogen, and other gases that are important to life. Under normal atmospheric condition, there are only 11 elements that are gases. This includes the diatomic molecules, hydrogen, nitrogen, oxygen, fluorine, and chlorine, and the noble gases helium, neon, argon, krypton, and xenon. These gases have common properties, including important fundamental properties that are measurable, which are mentioned and described in the recap, such as volume, pressure, temperature, and amount of gas or number of moles. Scientists have observed some activities involving gases. They found that the behavior of gases is determined by the behavior of its individual particle. In 1870, scientists formulated the kinetic molecular theory using a simple model of an ideal gas or a theoretical gas. The particles of an ideal gas behave consistently and in a predictable manner. Kinetic molecular theory of gases. According to the kinetic molecular theory of gases, the gas has the following characteristics. The first is gases consist of very tiny particles, each of which has mass. Under this, let's describe further. Gases are most likely empty space because of a wide distance between these tiny particles. Gases are highly compressible and have low density. The density of gases varies with changes in temperature and pressure. The second characteristic of gases is gas particles move rapidly in straight line, traveling constantly and in random direction. The third characteristic is gases diffuse rapidly that allows two or more gases to mix readily when combined. The forces of attraction, known as van der Waals force between the particles of gases, are negligible because of the wide spaces between them. The fifth characteristic, gas particles collide with each other or with the walls of its containers, but they do not lose their kinetic energy. It is only transferred to the lower energy particle and it will continue to move. Energy is conserved in an elastic collision of gas particles. The sixth characteristic, all gases have the same average kinetic energy at a given temperature of gas. The average kinetic energy of gas particles is directly proportional to the absolute temperature of the gas. This means that gas particles might have higher kinetic energy at a higher temperature or vice versa. The kinetic molecular theory of gases provides a model to explain behavioral properties of gases. The four measurable properties of gases, such as pressure, volume, temperature, and number of moles, are related to each other. If one of these variables is changed, there is a corresponding change in other variables, depending on its relationship. Gas laws are products of various experiments that were done by scientists many years ago. Boyle's law explains the relationship between volume and pressure at constant temperature. So you know already the four properties of gases. And we have to know the units that are associated with them. So for learning task 2, you have to familiarize yourself with the commonly used units for volume and pressure, remembering volume, pressure, and temperature units and their equivalent. For volume, in the SI unit, we have cubic meter, cubic decimeter, cubic centimeter. For the metric unit, it is liter and milliliter. For the English unit, we have the quart and the gallon. For pressure, for the SI unit, we have what we call the Pascal. For the metric unit, we have the atmosphere, the millimeters of mercury, centimeters of mercury. For the English unit, we have torr, pound per inch square or square inch. Remembering this all equivalents will also be of great help. For volume units and their equivalents, 1 ml is equal to 1 cubic centimeter, equal to 1 liter, equal to 1 decimeter, equal to 1 cubic meter, equal to 1,000 liters. Pressure units and their equivalents. 1 atmosphere is equivalent to 760 millimeter of mercury, equals to 76 centimeter of mercury, equals to 764. It is also equals to 101,325 Pascal, equal to 14.6956 per square inch. For temperature units and their equivalents, we have what you call the 0 degrees Celsius, equals to 273.15 Kelvin, or 32 degrees Fahrenheit. Next topic is called Boyle's law. For learning task 3, you have to read a short discussion about Boyle's law. The relationship between the volume and pressure of gases at constant temperature was first stated by Robert Boyle during the 16th century. He performed this experiment. He trapped a fixed amount of air in the J tube. He changed the pressure and controlled the temperature, and then he observed its effect to the volume of the air inside the J tube. He found out that as the pressure is increased, the volume decreases. He finally concluded that the volume of a fixed amount of gas is inversely proportional to its pressure at constant temperature. The general formula is V sub 1 P sub 1 equals to V sub 2 P sub 2. Where V sub 1 is initial volume, V sub 2 is the final volume, P sub 1 is initial pressure, and P sub 2 is final pressure. The formulas in getting V sub 1, P sub 1, V sub 2, and P sub 2 are here. To solve for the final volume, just remove P2 by dividing both sides of the equation by the second pressure. Then you cancel V sub 2 and V sub 1. So we come up with this particular formula. You have to use this formula in solving the sample problem below. Just substitute the value and solve for what is asked correctly. A sample problem is here. So suppose a freon in an air conditioning unit has a volume of 0.40 liter. It is allowed to function in a room where the pressure is about 600 millimeter of mercury. Assuming that the temperature is in a constant state, find the final pressure of freon when its volume is increased to 1 liter. Let's first identify the given. P sub 1 is equal to 600 mmHg. B sub 1 is equals to 0.40 liter. B sub 2 is equal to 1.0 liter. So you have to find the unknown, which is pressure, the final pressure, P sub 2. So we proceed with the formula. The formula that you are going to use is B sub 2 equals to B sub 1, P sub 1 over B sub 2. Substitute the value. B sub 1 is 0.40 liter. B sub 1 is 600 mmHg and B sub 2 is 1.0 liter. So for the solution, 0.40 liter times 600 is equivalent to 240 liter mmHg divided by 1.0 liter. And then our final answer is 240 millimeter of mercury. The importance of Boyle's law lies in being the first law to describe the behavior of gases. It explained that gases spread in the medium. It is the volume increases if the pressure is decreased and vice versa. Or if the volume decreases, the pressure is increased. So the particles are displaced from each other and they move easily if the gas is compressed, causing the volume to shrink. Gas particles have a very weak intermolecular force of attraction. Hence, they move as far as possible from each other. They have the tendency to occupy all the spaces they are contained in. If the pressure is increased, the volume will be decreased, forcing the gas particles to move closer to one another. Next topic is Boyle's law, problem solving. Learning task 4. Answer the following problems for a better grasp of the lesson. Problem number 1. Oxygen gas inside a 1.5 liter gas tank has a pressure of 0.95 atmosphere. Provided that the temperature remains constant, how much pressure is needed to reduce its volume by 1/2? First, we substitute the value. We identify the given. B1 is 1.5 liter, P1 is 0.95 atmosphere. B sub 2 is 1.5 liter. Since we only need the value of 1/2, 1 divided by 2 is 0.5. We multiply 1.5 liter by 0.5, the answer is 0.75 liter. We're going to find P sub 2. The formula that we are going to use is P sub 2 equals to B sub 1, P sub 1 over B sub 2. For the solution, first we substitute the value. B1 is 1.5 liter, P1 is 0.95 atmosphere, B sub 2 is 0.75 liter. 1.5 liter times 0.95 atmosphere is 1.425 liter atmosphere. Divided by 0.75 liter, our final answer is 1.9 atmosphere, which means that the volume is reduced, so the pressure is increased. Problem number 2. A scuba diver needs a diving tank in order to provide breathing gas while he is underwater. How much pressure is needed for 6 liters of gas at 1.01 atmospheric pressure to be compressed in a 3-liter cylinder? Identify the given. B sub 1 is 6 liters. B sub 2 is 3 liter. P sub 1 is 1.01 atmosphere. So we have to find P sub 2. For this one, our given B sub 1 is 6 liter. B sub 2 is 3 liter. P sub 1 is 1.0 atmosphere. We're going to find P sub 2. The formula that we are going to use is B sub 2 is equivalent to B sub 1, P sub 1 over B sub 2. First, it is followed by substitution. B sub 1 is 6 liter, P sub 1 is 1.01 atmosphere. B sub 2 is 3 liters. For the solution, let us multiply 6 liter times 1.01 It is now equal to 6.06 liter ATM divided by 3 liter. Please don't forget to cancel the unit of liter. So our final answer is 2.02 atmosphere. The volume is reduced, so the pressure must increase. Problem number 3. A sample of chlorine gas occupies a volume of 500 ml at 760 torr. Given that the temperature remains the same, calculate the pressure required to reduce its volume by 1/3. Let's identify the given. V sub 1 is 500 ml. V sub 1 is 760 torr. V sub 2 is 500 ml, but we only require 1/3 of that. So 1 divided by 3 is 0.33. 500 ml times 0.33, V sub 2 is equals to 167 ml. Let's find V sub 2. The formula that we are going to use is V sub 2 equals V sub 1 P sub 1 over V sub 2. Substitute the value. B1 is 500 ml, P sub 1 is 760 torr, V sub 2 is 167 ml. Multiply 500 by 760, we get 380,000 ml torr. Divided by 167 ml, cancel the unit milliliter. Our final answer is 2,275.45 torr. In here, the volume is reduced, so the pressure must increase. So let's proceed for Boyle's Law Activity 1. Let's compute and check it right. At the end of the activity, you should be able to solve problems using Boyle's Law equation. You have the following materials: calculator, pen, and paper. Read the given problem, fill in the table with the correct data, then solve and check it using the Boyle's Law equation, P sub 1, B sub 1 equals P sub 2 or B sub 2. So the problem is, in a J-shaped tube filled with mercury initially, mercury levels in both limbs are the same. The initial volume of the trapped gas in the closed end is 0.5 liter. The volume of the gas decreases to 0.3 liter after the addition of mercury from the open end of the tube. Take note that the open end of the tube is subjected to the atmosphere. Thus, the initial pressure is equivalent to 1 atmospheric pressure, or 1 atmosphere is equivalent to 760 millimeters of mercury. What will be the final pressure after the changes of the volume happen? We go with the first, this is the reminder that you should know and read. We go with the first column. Identify the given. V sub 1 is 0.5. V sub 2 is 0.3 liters. P sub 1 is 760 millimeters of mercury. We are going to find the final pressure, or P sub 2. For the first column, we go with the formula and the substitution. So for the formula, we use P sub 2 equals P sub 1 over P sub 2. Substitute the value. P sub 1 is 0.5 liter. P sub 1 is 760 millimeter of mercury. V sub 2 is 0.30 liters. For the solution, we multiply 0.5 liter by 760. We have 380 millimeter of mercury. Divided by 0.3 liter. Cancel the liter unit. We have 1,266.67 millimeter of mercury. We go with the second column for checking. We identify the given. V sub 1 is 0.5 liter. P sub 1 is 760 millimeter of mercury. P sub 2 is 1,266.67 millimeter of mercury. Find V sub 2. The formula here is V sub 2 equals V sub 1, P sub 1 over P sub 2. Substitute the value, 0.5 liters, V sub 1, P sub 1, 760, P sub 2, 1,266.67 millimeter of mercury. For the solution, 0.5 times 760 is 380 liter millimeter H of mercury, divided by 1,266.67 millimeter of mercury. Cancel the unit of millimeter of mercury. The answer is 0.30 liter, our final answer. For the third column, you have to identify the given. I will not anymore cite the given since you know it already. We go with the formula. So we go with the formula and substitution. The formula is P sub 1, this is equivalent to P sub 2, P sub 2 over B sub 1. B sub 2 for substitution is 0.30 liter. P sub 2 is 1,266.67 millimeter of mercury divided by 0.5 liter. For the solution, we multiply 0.30 by 1,266.67. The answer is 380 millimeter of mercury divided by 0.3 liter. Cancel the unit liter. Our final answer is 760 millimeter of mercury. So that concludes the first topic for week 1 about Boyle's law.